Okay, we're going to finish off day 2 of section 8 with the linear combination of unit vectors. So I'm going to draw a first quadrant, y, x, and I'm going to put some equal tick marks out. Okay, when we talk about our vector as being a comma b, what we're talking about is that it has pieces that made it up. The piece in the x direction, I'm going to put in 3 little green arrows here. I'm going to refer to that whole distance as I. And then I'm going to go up. I'm going to put in 4 little red arrows. I'm going to refer to that as J. And so our resulting component form here, or the combination of these, is up 4 over 3 is vector v. Okay? And of course, we're showing it here in component form. If we want to show it as a linear combination, it is AI plus B times J. So if we're asked to find the linear combination of the unit vector for DE. Given that D is -2 comma 3 and E is 4 comma 5. So to find that, DE is x2 minus x1, so 4 minus -2, and 5 minus 3. 4 minus a -2 is 6, and 5 minus 3 is 2. So as a linear combination, that would be written as 6I plus 2J. Now luckily, in this form of PreCalc, we're not going to be dealing with imaginary numbers. Otherwise, that I becomes a little disconcerting because we think it's an imaginary portion, but it's not. Okay, and we can, so 6,2 as a component form is the same as the linear combination of 6I plus 2J. Okay? If we want to look at this from another aspect, going back, looking at it from a little bit of the trig perspective, we can draw out our axes. And if we have vector A, and we have vector B producing component vector V that ends at point A comma B, we know a few things from trig when referring to this angle right here. Sorry. And what we know about that angle is that A is equal to the length of our vector times the cosine of A. The cosine of theta gives us A, because cosine is adjacent over hypotenuse. For B, we know it's the sine gives us opposite over hypotenuse, so B is the length of V times the sine of theta. Pulling those straight out of last semester. So our component vector V is its length times the cosine theta gives us the x coordinate, and its length times the sine of theta gives us the y coordinate. So we can find the component form of a vector V with a magnitude of 10 and a direction angle of 120 degrees. And to do that, we know that the component form is going to be equal to that magnitude of 10 cosine 120 and 10 sine 120. Make sure you are in degrees on your calculator when you type these in. 10 times the cosine of 120 gives us a -5, and 10 sine 120 gives us a decimal. We'll round it to 8.7. Okay, so very straightforward and tying back into the trig we learned last semester. Okay, last part of day 2 is direction angle. Let me start over. Direction angle theta of vector V equals A comma B can be found by taking the tangent. tangent of theta is equal to B over A, or opposite over adjacent. Now there's a problem with this, and that is that your calculator when we look at tan, reversing the tan function, tan negative 1 on the calculator, that is only able to produce only quadrant 1 and 2 values, because then they start repeating themselves in quadrants 3 and 4. So you must adjust if A comma B is in quadrant 3 or 4. So let's look at that. So find the direction, angle of the vector to the nearest tenth of a degree. Okay? So for number 1, we have 3i plus 7j. Well, we know that that's going to be in the first quadrant because both the 3 and the 7 are positive. So we have a positive x, a positive y. So we know we're in quadrant 1. So to take and find theta is simply tan negative 1 of 7 over 3. And when we type that into our calculator, making sure we're in degrees, we'll get 66.8 degrees. If we look at negative 2i minus 4j, well, negative 2 means we're going back to the left. Negative 4 means we're down. We're in quadrant 3 on this one. That means we have an issue. When we take and get the tan negative 1 of negative 4 over negative 2, those negatives cancel out, so it's giving us the appearance of a first degree angle. And your calculator does that and gets 63.4 degrees. We know that's not right. What do we do to fix it? We add 180 degrees and we get 243.4 degrees, moving us down into the third quadrant. We got to bring ourselves half clock around. Okay? That is it for section 8.2, and that's the end of chapter 8 for us. We don't go past 8.2 in this chapter. So have a good one.